Hello again. So we are all set to start developing the program that implements various operations for double linked list data structure using C programming language. I hope you have downloaded this program there in your hard drive and you are ready with your favorite IDE to go with me. So let's go ahead and start writing the implementations. We'll start with this init list function. I'll copy this. I'll go to the end of the file, and this is going to be a very simple one, and we already did that in case of single linked list. So this is the implementation of init list method. Now it's going to be very simple. We are just going to initialize the head and the tail pointer to null. I hope you know why we are writing arrow there instead of dot, because lstptr is the pointer to the double linked list object that is there in the main function, or the function that calls this init list and that passes the address of that object. So if you need to access the structure object members using the pointer, it should be arrow instead of dot. So that's why we are using the arrow here, because lstptr is a pointer to the structure object. So lstptr arrow head equals null, and then lstptr arrow tail, that should be also null, and then lstptr arrow node count, that's going to be 0. So that's our first implementation, the init list. So next we'll be actually doing the add first method. Okay, let me copy the add first method's prototype there from the beginning of the file. Here it is at line number 28. I'll copy that. I'll go to the end of the file and I will just paste it there. So here's the implementation of add first method. So let me just explain what's going to be the logic for this add first method, and then we'll start writing that. Okay, the first thing that we need to do there in the add first method is to create the new node. That's the very first thing. So step 1 is actually create the new node dynamically using malloc call, then assign the node content with data, initialize the previous and the next pointer, with null, because this is the node that may be the first node and last node. So if we need to assign something else, then we'll do that later on. So initially we are just putting null there in the previous and the next pointer. Now the important thing is that if this is the first node that we are adding with the double linked list, that means if the head and the tail pointer both are null, then this is indeed the first node that we are going to add into the double linked list. Then we need to assign the address of this node to both head and tail, and we'll increment the node count by 1 and we'll return from this function. Otherwise, if it is not the first node, then we need to insert this node as the first node. That means there are many nodes in the linked list and we need to insert this as the first node. So let us consider these two situations one after another. One is if the linked list is empty and this is the first node, this is the last node. Another is there are many nodes and we need to insert this new node as the first node. So I'll draw the picture and I'll show you both the situation. So if this is the case, the linked list is empty, both head and tail are null, and we have this node for the double linked list where we have initialized both the previous pointer with null and the next pointer with null, and we kept that data set 10 here that we have passed here in this data variable as parameter. So now what we are going to do, since the linked list is empty, we'll put the address of this node there in the head and the tail. So if this is 1000, then we'll keep that 1000 there in head and tail as well. So here we go. So we assign 1000 here and also 1000 here, there in tail. So both head and tail are pointing to this. And so we are done with this. I mean, we have added the very first node with the linked list. Now, if this is not the situation, we have many nodes there in the linked list. Say we have this situation, That's the second condition, right? The linked list is not empty. And we had this situation. 1000 is the address of the first node, and that is there in the linked list head, and 2000 is the address of the second node. That's 3000 is the address of the third node, and tail contains 3000. And the previous pointer of the second node is obviously 1000, and the next pointer of the second node is 3000. It's 2000 there in the next field of the first node. It's null there in the previous field of the first node, and it's 2000 there in the previous field of the third node. That's the last node. Now we had this new node. Say this node is pointed by new pointer p. So the previous is null and the next is null, and we have this data 5 there in the node contained. So we need to insert this node as the first node. So how we are going to do that? So actually the head is going to point to this node, and the next field of this node is going to point the current first node, and the address of the current first node that you can get from the head. So first of all, what we will be doing, we'll be actually copying the content of head to the next pointer field of the new node. So if we do this operation, then the content of head, that is 1000, that is copied here, and so that this node next field, the new node's next field, is now pointing to the current first node. Now the current first node previous field, that means this one, let me change the color there. Okay, so blue is good. So this previous field, now this is going to point to this new node, because the new node is going to become the first node. So what we'll be doing, the head arrow prev, that is the current first node's previous pointer, that's going to be assigned with p. Now p is actually the address of the new node. Say the address of the new node is 5000, so p contains 5000. So here what we are doing, we are assigning 5000 to the previous pointer field of the first node. So here we go, 5000 comes here, and this previous pointer is now pointing to this node. Now what we need next is that this new node now is going to become the first node, so we need to update the head. So the last thing that we need to do is to update the head equals p. So now head is going to contain this address of the new node, that's 5000. So head is no longer going to point to that node that it was pointing previously. Now head is going to point to this node. Now you can see that that node, this new node pointed by p, is now the first node of the linked list. So these are the three operations that we need to take care of. P arrow next equals head, that means this pointer field is updated with the first node's address, I mean the current first node address, that was there at the head, and then we actually taken care of the previous field. So head arrow previous, that means this field is updated. Then finally we did updated that head so that the head points to this new node. So this is how we do that. So let me just go ahead and write the code there. Okay, here we go. So I'll write the algorithm first. So if the head is null, or if the node count is 0, that means the linked list empty, then both head and tail will be assigned with the new node that we created using the malloc call. Otherwise, we need to just do those operations. I mean the new nodes, if the new node is p, and then p arrow next, that's going to be assigned with current head, and then the head arrow previous, that's going to be p, the new node's address, and then finally we need to update that head equals p. So these are the three operations that we need to take care of there. So let's do this now. I'll write this there. Okay. So first of all, we are declaring a node pointer p, and we'll do the malloc there. If we are unable to create that node, if malloc fails, then we can just display a message there, and then we can just return from this function. Otherwise, the node has been created, so we can just assign the data, and then we'll assign null to both next and the previous field, and then we'll check if the linked list is empty. lstptr arrow node count. If that is 0, then obviously the linked list is empty. In that case, lstptr arrow head equals lstptr, that's the pointer to the linked list object, equals the new node's address. Otherwise, we need to update this. I mean, the p arrow next is going to be the current head, and that is there in the lstptr arrow head. And then head arrow previous equals the current node, and then we need to update the head with p. And in both the cases, we have added one node there, so the node count must be incremented by 1. So we are done with this. Add first is done. So we'll check this after we write the add last in the next tutorial. So we'll be writing the add last method in the next tutorial. A small correction is required there. I have just used head there. We do not have any variable named head. It's there inside the structure object, right? So in order to access that, we need to use the structure pointer. So lstptr arrow head arrow brief, and here also it should be lstptr arrow head. So that's all for this. So we'll be writing the add last method in the next tutorial. Before we do that, I want you to just complete this section. I mean, just pause this video and go to your IDE and type this function. You can just look into the algorithm that I have written there at the top of this, and can just go ahead and type this function in your IDE before we go and implement the add last. Okay, thank you for watching.